Hey class, this is Kay Maney, and I know that you have your midterm exam coming up real soon, and you might have some questions about the midterm review. In fact, there was a question that was posed to me, and I've decided that it's difficult enough that I was going to make a video to help with it. It was number 18 on the midterm review. And not everyone has the same number 18 on the midterm review. Every time you run it, it generates a different question. However, they are similar. So I wanted to address this problem in case anybody else is having a problem with it, because one student did ask me about it, and I think we need to talk about it. So here's what the question is, and I have it written on one board. Then I'm going to move over to another board. So I'm sorry that I'm having to move around here because I didn't have enough room. But here is the question that's being posed. And I may kind of come over here to this again. I hope you can see this. Okay. It says to determine the probability that at least 2 people in a room of 13 people share the same birthday, ignoring leap years and assuming each birthday is equally likely by answering the following questions. Part A, compute the probability that 13 people have different birthdays. Part B, the complement of 13 people have different birthdays is at least 2 share a birthday. Use this information to compute the probability that at least 2 people out of 13 share the same birthday. All right, so let's do part A. Part A, we're going to compute the probability that 13 people have different birthdays. Okay, now to do that, we're going to come over here to this other board. And I'm going to see if you can see what I did here. Okay, let's start out with the top row. Notice on the top row, just a minute, let me put this in this little holder thing. I think it'll be better. There we go. Hopefully you can see that now. Okay, here we go. The top row shows you that I've started out with 13 blanks. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because I wanted to know about 13 people. And I want them all to have a different birthday. So if you think about it, there's 365 days in a year. So the first person, we don't know what their birthday is, but we know that it's one of the 365 days. So this slot right here has 365 different choices for their birthday. But the next slot has one less than that, because once this guy has a birthday, this guy cannot have the same birthday. This one has to be different. So I just lost one of those 365 days. So now I only have 364 days to choose from for this person's birthday. And the same thing just keeps on happening down the line, because you cannot reuse a day. Once you've used it, you cannot reuse it. You're not putting it back in the pot. So on and down here, you just keep on going down one. The next person only has 363 to pick from, etc. I hope that concept makes sense to you. I wrote them all out. When you get down here, you're finally down to 353. Now that's just the number of, we call that permutations that can be made from 365 days, picking 13 out of the 365. Okay? We could multiply this all together. It's going to be a big number. But the question was not just how many permutations you can make from that. The question was, what was the probability of 13 people having a different birthday? Now remember, probability has to be a number between 0 and 1 inclusive. So notice that you have to have a sample space when you're talking about probability. Our sample space for this problem is 365 numbers, because we have 365 days in a year. So each one of these, you'll notice the second thing I did was I took each one of the numbers I had up there on the top line and I had to put 365 underneath, because the probability for the first guy would be 1. He absolutely, we're going to be able to find a day that he was born that year, because one of those days is going to be his birthday. Okay? So that's a probability of 1. He absolutely has one of them. But remember, we can't repeat. So each one of these numbers that we had up here, we now have to put it over 365, because remember, you have to have a sample space. And there are 365 numbers in the sample space for each person's birthday. So now I've created these fractions that are between 0 and 1 inclusive. This represents my answer. The thing is, I've got to compute it. So the easiest thing to do is just take your calculator, multiply all the top numbers together, hit enter, then say divided by, and put 365 to the 13th power, because you've got 13 of them. Remember now, multiply all the top numbers and hit enter. It'll compute that. Then say divided by 365 to the 13th power, because you've got 365 times itself 13 times. That's the easiest way to put it in the calculator. And if you hit enter after that, you will get this first decimal. 0.8056 is our answer to A. All right. Now back over to B. I'm going to go back over here so you can remember question B. They're sort of leading you through the problem, which is very nice and very helpful, because they said part B is the complement of 13 people have different birthdays is the same as at least 2 people share a birthday. Now, I'm not going through all the theory of why that's right. That is in your book, okay? So since they're helping you here, all you have to do is find the complement. And, of course, we're supposed to know what that means. So all we have to do is find the complement of A in order to get our answer to B. So let's go back over here, and we find the complement, and we know that the complement is always 1 minus the answer that we just got. So when we subtract that answer from 1, we do get 0.1944, because a complement means this number plus that number has to equal to 1. Okay? So this is your answer to part B, this is your answer to part A, and that final answer is actually the answer to the entire problem. I'm hoping this is going to help a little bit. I'm going to post this on YouTube, and then I'm going to put an announcement out. You may just want to watch it even if you felt like you didn't have any trouble with number 18, because you don't know when you get to the midterm, it could generate a problem very similar to this one with different numbers. Okay? So I don't want you to miss it. I hope this helped. Please let me know if this helped or not. Thank you, and I look forward to meeting some of you on Tuesday. Thanks. Bye-bye.